Platform 9 Cloud Native live stream and podcast. This is Kamesh Pemmaraju, product marketing here at Platform 9. I'm excited to have Joe Thompson join us today. We're going to kick off a new series on Kubernetes and resource management and utilization, which is a hot topic these days because of cost optimization and focus on reducing costs across the board. So let's dive into it. Joe, you've had a storied career in IT and tech, and more. I guess you've been doing a lot of stuff in Kubernetes and orchestration and all of this good stuff. So why don't you introduce the audience about yourself, and then we'll dive into the topic of today.
Yeah, so I guess I started way back in the days. My first jobs in IT were actually working for small local internet providers when, you didn't even necessarily have a rack. You just had like a stack of servers in the corner. And then I moved up from there. I started off doing desktop support, user support, moved up into system administration, and then later on did a turn in consulting and got more into architecture there. And as I was getting into architecture and infrastructure more, that was also around the same time that virtualization was becoming a big deal. VMware was taking off and everybody was converting their infrastructure to be virtualized. And I did that for probably 4 or 5 years. And that was about the time that Kubernetes came along. In 2014, 2015, everybody was getting excited about containers and kind of looking at it and going, what can you even do with this? And then Kubernetes came out and answered part of that question. And at the time, I was working at Red Hat, and I looked at it and said, well, this is really interesting. This is actually something that I think is going to be big in the same way that like Linux became big back in the day. And so I jumped on that. I went from Red Hat to CoreOS. I worked for a couple of end user companies. And then I ended up going back to work on the vendor side. I worked at Mesosphere and then HashiCorp, and now I'm here at Platform 9, kind of getting back into infrastructure again.
That's awesome, Joe. Welcome to Platform 9. Joe has been here for a couple of months, really digging into the technical aspects of Kubernetes. And in particular, he's focusing on this whole issue of resource management and utilization of Kubernetes. I was just following, although we were not at KubeCon this in Paris, Joe. I've been following all the noise that's coming out of it. There's a lot of discussion about AI and Kubernetes, and I'm just thinking, once you have generative AI, the amount of resources that would be used would be ginormous, right? And especially if you're in a public cloud, I don't know how much that's going to cost people. It just seems like it's going to go through the roof, right? So, what are your thoughts on in general? So, kind of, we'll dive deeper into the topic of today, which is really all about how do you manage how does Kubernetes actually manage resources? We think it's highly efficient. Is it really? How does it manage utilization? How do workloads get scheduled onto nodes, et cetera, et cetera? Before that, Joe, just a high level thoughts on AI and Kubernetes and the workloads that are out there around the Kubernetes ecosystem. Let's jump into
So
that first.
there's actually an interesting disparity there because with AI workloads, something's beeping at me. Sorry about this. I don't know what it is.
We
Oh,
can hear you okay.
hold on. Let me mute myself real quick while I figure this out.
You're able to hear you okay, Joe.
I don't know what
Okay.
that was, but I just unmuted my mic and it went away. So let me,
You're not on screen, but I think we're able to
oh,
hear you fine, Joe. Yeah.
okay.
Yeah.
Let me see if,
But we can't see you yet.
yeah, let me try this. Let me get rid of my background. No, that doesn't do it. All right, let me change over to, well, I'll just keep talking and see if I can figure this out on the back end. Um, Let me switch my camera here. Anyway, with AI, there's basically two kinds of workloads that you have to deal with all the time. One is you have, of course, the training and the kind of learning workloads, and that's very batch oriented. So you're going to do a big data ingest run. You're going to classify data, and then you're going to feed it to your AI so that it can learn. But then also you're providing that service to something else that is, you're providing a service to a user or to some other system. And that load is liable to be more like a regular, web front end service. It's going to go up and go down, but it's not going to be like a batch oriented workload where it's very spiky, where you have a huge load at certain times a day, and then you have almost no load at other times a day or during the week.
Hmm.
So it
Hmm.
can be a challenge to schedule those appropriately. I know some solutions providers have actually gone as far as to write their own schedulers that you can use to manage that better. So you can actually run multiple schedulers in Kubernetes, and the workloads that look more like regular web workloads, you can just let them run in the default scheduler. And the ones that are more tailored to the AI learning process, you run those in the custom scheduler.
Hmm. So it seems to me, really, the utilization of resources by Kubernetes is highly dependent on the type of workloads that you're running. Oops,
Yeah,
looks like we, yeah, okay. I
I
can't
would
see
say
you
that's,
anymore.
oh, you can hear me though, right?
Yeah, I can hear you. Yeah, go
Okay.
ahead.
Yeah, I would say that's fair. It can be challenging, especially because with those batch workloads, you go from essentially zero resource utilization to massive resource utilization in a lot of cases.
Hmm. Yeah. All right. So why don't we dive into the topic of today, which is resource utilization? So let's kind of go to the basics first, Joe. What's the
Uh-huh.
most basic way of managing utilization in Kubernetes?
So Kubernetes lets you set a request and a limit for various resources that a container can use. And then based on the way you set them, you have the resource and the limit themselves, which set the raw resource utilization. And then based on how you set them, Kubernetes also assigns something called a quality of service to that pod. It can be best effort, or it can be burstable, or it can be guaranteed. And what that determines is how likely is the kubelet to stop running that pod if the node that it's running on becomes overloaded. So there is this concept called resource pressure. And for some resources, to relieve that resource pressure, Kubernetes will actually begin terminating pods. With others, like CPU, it won't terminate a pod, but it will start to throttle things as resource pressure becomes greater. And so when you start getting into resource pressure territory, those best effort pods are kind of the first to go. They're the first ones to get throttled or the first ones to get evicted, depending on what resource it is. And the guaranteed pods are the last. So it doesn't affect how those pods are scheduled in the first place. Like a guaranteed pod can't push a best effort pod out of its way to get scheduled, but it does affect how long they're liable to continue running when resource pressure hits.
Hmm. So what happens when a pod gets evicted?
So if a pod's evicted because of resource pressure, that is basically the kubelet saying it basically number one, the kubelet takes notice that the node is under resource pressure. And that triggers this eviction behavior where it starts looking for candidates to evict. And it has several criteria for that. One is that if a pod is using more than its resource request, then it is a candidate for being evicted for certain, like for memory resources, basically for incompressible resources like memory or huge pages. That makes it a candidate to be evicted, to be terminated. Uh, with some things, like with a guaranteed pod, The only time a guaranteed pod will ever be evicted is if it actually exceeds its resource requests. That's the basic difference there. Is a guaranteed pod never exceeds its, or excuse me, I said resource requests. I should have said resource limits is when a guaranteed pod gets evicted. The only time that a guaranteed pod is ever a candidate for eviction is when it exceeds its resource limit, because what defines a guaranteed pod is that its limits and requests are the same for every resource.
Mhm. And once the pod gets evicted, what happens? Does it get rescheduled on to some other node?
It will attempt to be rescheduled. The scheduler will see that this pod has been terminated, and then it goes back in the scheduler, and the scheduler says, all right, where am I going to put this thing now? Probably not back where it was, although that's not unheard of. You sometimes get these transient spikes, and a pod
Mhm.
will get evicted, and then it will go right back on the node that it just got evicted from because the spike
Yeah.
went back down. But usually it's going to try to put it onto another node. Now, in a
Mhm.
heavily utilized cluster, that can sometimes be a problem because depending on your resource utilization, you may or may not have enough of a given resource. Kubernetes won't evict a pod because of CPU constraints, but it will refuse to schedule a pod if it's
Mhm.
requesting more CPU than it thinks a node has available to give. And so as your cluster gets more and more utilized and you start to see these pods get evicted for resource pressure, it gets more and more difficult for them to land anywhere else.
Right. So we're talking about resource constraints and resource pressure, and wouldn't isn't it possible to just add more nodes and relieve that pressure rather than doing all this part evictions and movements and stuff like that?
You can do that, but the problem with doing that is that you can end up there we go. I think that's a
Are you
little
back?
better. I'm back. I'm in a kind of a weird position here. Let me move this down a bit so that I'm more okay. And if we move that up there. Okay. So you can relieve that pressure by adding nodes. But if the problem was that your workloads weren't efficient in the first place, then you're just actually making that problem worse. Because
Mm,
what you've done is you've overloaded your nodes with inefficient workloads that are, requesting resources they're not even using. And then when you run out of space, it's kind of like stuffing a closet full of empty boxes. The solution is not to go and build another closet. The solution is to figure out how you can make the workloads that you have, the boxes that you have,
mm.
fit in the space that they actually should take up.
Which brings us to the question: if you have important workloads, you mentioned different types of scheduling or quality of service um, ways in which Kubernetes schedules, like best effort and guaranteed. But what if you have very important workloads and you want to make sure they do get scheduled in a cluster that's already resource constrained? How can you ensure that?
Kubernetes lets you set something called a priority on a pod. And there's two ways to set it. One is you can just set a numeric priority. And the other one is there's actually a resource called a priority class that essentially lets you give a numeric priority a name so everybody knows what it means. And so you can set that priority on that pod. And then what will happen is when the scheduler is trying to schedule that pod, it will look at nodes. And if there isn't a node that already has enough free resources to schedule that pod onto, it will actually start ordering the kubelets on those pods to terminate, to evict lower priority pods. Now,
Mhm.
there's some rules that it uses for which nodes are candidates to force that to happen. And then those nodes, then the individual pods on them have to be candidates to be evicted or to be what's called preempted. So the previous, with resources and limits, you have this kubelet management process called eviction. With priorities, it's a scheduler managed process called preemption. And so a node has to be a candidate to have pods preempted, and then some of those pods have to themselves be candidates for preemption as well. And there's a weird thing there, which is I said you can set it numerically or you can set it with a name. A lot of clusters will be running a webhook that says you can't set a numeric priority. You have to give it a priority class. And that's basically one way to make sure that people aren't just setting arbitrary priorities without even knowing what they represent, right?
Mhm. So when you assign a higher priority to one of these pods, what's essentially happening looks seems to me that that pod will get priority, and then some other pod will be replaced in some ways, right? Isn't that what's happening?
That is exactly what's happening. So basically,
Yeah.
on the backside, once a pod has been identified as a candidate for preemption, it's kind of the
Mhm.
same thing that happens with eviction. The pod gets terminated, it goes back into the scheduler. The scheduler is now going to try and reschedule it.
Mhm. Mhm.
But again, if your cluster is extremely utilized, especially because now you have a higher priority pod taking up the space that preempted pod formerly took up. Things are actually more resource constrained for that pod than they were before.
That's true. So all these evictions and preemptions, all of this activity that's going on, right? It's pretty complicated, right? And it sounds like it's almost like an art on how you set up these priorities and these classes, right? Of quality of service and so on. It just seems to me it's a very difficult thing to really get that perfect balance of what these numbers should be, right? These knobs and dials that you have access to as a developer or DevOps engineer. How do you even know what's the right set of dials and what's the numbers you should be doing? I mean, is it experimentation? Is it Are there tools that help with that, or what? How do people do this?
Some of it is just plain experimentation. And I mean, in the beginning, that was all you could do. It was just like
Yeah,
with virtual machines back in the day. How big should your virtual machine be? Well, how much
yeah.
resources does your workload need?
Hmm.
With virtual machines, what people quickly landed on was the idea that, yeah, we might know what this workload needs right now, but it's not a static workload. Sometimes a
Hmm.
spike of activity comes in. I mean, back in the day, we used to say, you just hit the front page of Slashdot, which was a very
Yeah.
popular text site. It's still around. And,
Mhm.
you would get slash dotted, which was the slang term for so many requests come in all at once that your website just falls over. And
Yeah.
so, you have that kind of dynamic today as well, where you could have a virtual machine, which gets, it's running a service that gets slash dotted. And so there came to be this idea of how do we allow enough headroom where we can handle that kind of spike, but not be taking up so much resources that can't be used for other things in the meantime until that spike happens. Virtual
Mm.
machines came up with the idea of overcommitment, basically, where you can say, all right, I want this virtual machine to, in theory, be able to use this much memory. But in the meantime, while it's not actually using it, that memory can be used by other things. And one of the difficulties with containers and Kubernetes is there is no overcommitment. You just have to size things properly. And that's a big challenge. And there's a lot of tools that are coming out now where their whole function is just to look at your currently running pods and say, I know how big this pod's requests are, but how big should they be? And then
Mm.
possibly change that.
Right. So let's dive into that a little bit more, right? So requests, limits, priorities,
Mhm.
all of these quality of service. So what are some of the issues that can occur when people are trying to manipulate these parameters, and what happens in practice?
So a big one that can happen is by default, if you have the ability to set a priority class on a workload, which most users do in most pipelines in practice, you can set any priority class you want. And the two that are built into Kubernetes out of the box are very, very high ones because they're intended to be there to allow cluster critical and node critical workloads to always be able to run. But if you're a user and you're setting a high priority on your, whatever microservice it is that you're running, you could end up pushing things out of the way. Now, sometimes people just do this by accident. They go, well, okay, it's a very important workload. I want to make sure that it runs. I'm going to call it, cluster critical. Uh, and so they set that, and the pipeline happily submits it, and Kubernetes accepts it, and then something disastrous happens because it turns out that that workload pushes another actually more important workload that didn't have a priority out of the way. Um, and that could be done accidentally. It could be done maliciously. You have to watch out for that. There are ways that you can limit that. You can limit which priorities users can set, but Kubernetes doesn't do that for you out of the box most of the time. Um, the distributions that I've looked at don't do it out of the box. I'm not discounting the possibility that somebody's distribution does. Uh, and it's all right there in the documentation. You just have to go read the documentation, find that one particular piece of the docs that tells you exactly what to do, and then do it. But if you missed that, then you're kind of in this state where anybody could do this at any time, and you wouldn't know about it until something fell over that shouldn't have fallen over. The other
Mm,
thing that can happen is because you have essentially two different systems of determining how important a workload is. And there are some special rules about the way that Kubernetes handles preemption. So you can actually get into a situation where a lower priority workload is blocking a higher priority workload from running on that pod, even though there's theoretically enough space if some of the workloads were evicted to make room for that higher priority pod. And you look at this in the documentation and it actually warns you against it, but it's another one of those things that if you aren't aware of it, and I think probably most people aren't. I think most people
mm.
probably have not read the documentation down to that level with that degree of care. It's one of those things that you find out the hard way when it bites you and some critical service falls over in the middle of the night on a Saturday.
That's the last thing you want if you're responsible for the uptime of your cluster, right? You don't want that wake up call.
Yeah, well,
So let's, yeah,
as I say, the cluster itself, in technical terms, is fine. The cluster is operating. It's just what you
yeah,
wanted to be running in your cluster has suddenly stopped running, and why?
yeah, yeah. So let's talk about utilization. So all of this stuff, right? People set priorities. They figure out the best case. Whatever the dials and nods, limits, and so on. What happens in practice? And I've been reading some of these utilization numbers. Datadog had a report out, and we have ourselves seen at Platform 9 talking to various customers. The overall cluster utilization on average appears to be pretty low in practice. It's somewhere in the 20 to 30% range. Why is that? I mean, if with all these dials and knobs and priorities, can't you just make the utilization better? What's preventing people from doing that?
You would think so. And I think it comes down to two things. One is there are a lot of tools out there. And so you have this kind of, when I worked for other companies, part of their sales pitch about their Kubernetes distribution was strictly how complex it is just to sit down and look at the options and make a choice, right? And so one company I worked for, they actually had like a marketing video where they kind of drew out, if you want to run Kubernetes, you have to decide which distribution you want, and they, put a dot on that huge CNCF landscape. Then you have to decide what service mesh you want, and then a line goes over to service mesh. Now you have to decide what storage system you want. Now you have to decide what monitoring system you want. It's kind of like that, but it's all just in the realm of workload management and resource management. There are so many options to choose from, and they all do slightly different things in slightly different ways. And so I think number one, a lot of people administering Kubernetes clusters just take a long time to decide even which one they want to start with. Then they finally decide on one, and it takes them a long time to figure out what do we want this thing to actually do? How do we want to set it up? What do we want it to actually control? And then, having done that, sometimes it just takes them a long time to get those parameters right, to figure out, okay, it should auto scale this, it should not auto scale this, it should alter this workload's resources, it should not alter this other workload's resources. And all this time, you all constantly have that background, kind of anxiety of we have to step very carefully, because if we don't do things very carefully, this can actually take down production if we get it wrong.
Right,
So
right.
they tend to be more conservative. It's easier to throw money at the problem than it is to explain to somebody why production went down in the middle of in the middle of the day on a Friday.
Right. Okay. So now, but there are tools. There are tools out there. I know there's a horizontal pod autoscaler built into Kubernetes. And there are also vertical autoscalers and tools like Carpenter, which are supposedly solving this problem. And some way, shape, or form. What are your thoughts on that?
Yeah, so there's a lot of stuff. Some of it is, like you just mentioned, the horizontal pod autoscaler. That's built into Kubernetes. That's one of the first tools that actually was made available for this kind of thing. And the HPA is, most people think of it as a scale out, right? We have this thing that we want to run at one replica, and then when traffic gets busy, the HPA is going to explode it out to 4 or 5 or 8 or however many replicas it needs to handle the traffic. So that's built into Kubernetes. The project also maintains a couple of other things, because the horizontal pod autoscaler doesn't do any good if you don't have enough resources free on your nodes in your cluster to actually run those additional pods. So another one that showed up early on was the cluster autoscaler. And so the cluster autoscaler will actually go back to your cloud, infrastructure and spin up new nodes to join to your cluster. One of the things with that is that means that something somewhere is going to have to handle a credential for your infrastructure, whether that's an external service or whether it's something running in the cluster itself. The cluster autoscaler or some other tool that you're using to do cluster autoscaling now has the capability. I saw a really good tweet once that said, remember that the cluster autoscaler is connected to your checkbook, because as the cluster autoscaler fires off, you're spinning up all these nodes. They're not free. And so the cluster autoscaler, I think, was one of the things that made people realize, oh, workload efficiency actually matters, because if our workloads are inefficient, when the cluster autoscaler fires off, it's just spinning up new nodes to handle more and more of these inefficient workloads. We're spending more and more money, and we're not actually getting the benefit that we should be. So then you get things like the vertical pod autoscaler, which will actually try to resize pods themselves, deployments actually, to match their resource utilization with their resource requests. The trouble with that is that currently that is a disruptive operation. So the way the vertical pod autoscaler works is it changes the deployment manifest, and then a deployment rollout happens. Old pods get terminated, new pods get started. But there are some things that just don't handle that well. They theoretically, every workload running in a Kubernetes cluster should be able to handle 1 or 2 pods going away at once. The reality is that's not true of every workload. And so sometimes you get these workloads where if you put the vertical pod autoscaler on them, it's going to affect your production services
You
availability.
probably don't. You probably don't want. So it sounds like that's the last thing I would want to be disrupting my application, because if I'm a developer, I have SLAs to deal with, right? And my users, I don't want to disrupt my users. That's the bottom line. So I have a question around this vertical autoscaler. You said you have to change the manifest and redeploy. Basically, you're doing a new deployment essentially,
Mhm.
right? Because you're
Yeah,
changing all the. I'm assuming you're changing limits and requests and priorities and things of that nature, right?
exactly.
Because you
Yeah.
want to scale you want to vertical, you want to increase the size of your pod essentially, because you've gotten data that it needs more memory or needs more CPU, and therefore you're adjusting your limits and requests. And when you do that, you're creating a new deployment and you're rolling it out, and that means you're restarting those pods, and therefore there's a disruption, right? Now,
Yeah.
you don't want a tool. I don't know if there are tools that do this automatically, but if I were the engineer responsible for this, the last thing I would want is a tool to change these things automatically.
You get that. There can sometimes be that exact tension between the application engineers who are saying, hey, our application doesn't react well to having some pods just suddenly terminated, right? But then
Yeah.
you also have the infrastructure administrators going, okay, that's fine, but your application is requesting resources it's not using, it's costing us money, it's affecting our ability to run other people's important applications in our cluster. Uh, so we need to be able to do something to reconcile those resource requests with what your application is actually doing at any given time. And so the Kubernetes project now has an alpha feature for live resizing of requests. In other words, instead of it being a disruptive operation like a deployment rollout, the pods themselves now are not immutable like they used to be with requests and limits. There are some caveats to that. And even then, even when you're doing that kind of thing, there is still the risk that, oh, okay, whatever we used to decide how much these requests actually should be, got it wrong. And so it resized our pod's requests up, but not enough, or it resized our pod's requests down. And then there was a spike of activity and our pod got evicted because it exceeded its
Mm.
so
Right.
even with that live change capability, in place change capability, it's still not a silver bullet.
Mm. Interesting. Now, in a real world scenario, I'm just thinking about what happens in a typical Kubernetes shop that's running large scale workloads. You would have an engineering team, right, building applications and containerized applications, and you'd probably have an SRE and a DevOps team that's focused on keeping the cluster up and running, right? And maybe looking at the utilization of the cluster, looking at all the memory usage and so on. So in a scenario like that, right, the DevOps people are responsible for the upkeep of the cluster. And maybe given the whole FinOps movement that's happening, Joe, and that's a whole different topic we should cover in a future podcast to discuss about the FinOps aspect of it. There's somebody within that DevOps FinOps team that's looking at this data and saying, we're using maybe 20% of this cluster. And then someone in the FinOps team is saying, we're spending, the checks are going out of the door, right? These big checks are going out of the door. And then they come back to the engineering team and say, hey, guys, can you make this more optimized? Can you increase the utilization of this cluster? And then there seems to be a pushback based on everything we discussed today, because this is so complicated. There's so many things you have to adjust, and none of the existing tools seem to solve the entire problem. What does that dynamic look like? How would this, what's your, in your experience, how does that look like in the real world?
Well, yeah, I think there is kind of that tension between those two actions, if you will, even in a DevOps environment where theoretically everybody's on the DevOps team, right? And they're all working toward the same goal. But you do have, people who are writing applications want to make
Yeah.
sure that their applications are running with as much resources as they can get so that their apps are stable, so that their apps don't have to deal with sudden spikes. Um, but of course, the infrastructure people want everything to run in as tiny a space as possible because
Right.
either they or the people they report to are the ones actually writing the checks. And so everybody wants to. Now, you don't want to overdo it, right? You don't want your cluster to be sitting there at like 90% utilization because then you don't have any headroom for those spikes when they happen. But you
That's
also
right.
don't want it to be sitting down around 20 or 30% either, because that means that you're writing checks, spending a lot of money that literally does nothing. It's just resources that are sitting there idle. And it's not a Kubernetes thing, even specifically, because I remember in a lot of the virtualization environments that I worked in, it was the exact same thing.
Yeah, that's right.
The application teams would say, all right, we need 3 virtual machines and we want them to be this big. And the infrastructure team would say, well, show us your application actually using that amount of resources and needing that number of VMs. And there would be this constant argument back and forth of we need more, but we don't have more to give you. You need to use less. So
That's a
it's
constant tension. Yeah, it's a
it's a
constant tension.
it's a very old story, and it is a
Yeah.
story that continues to be told today.
So then let's kind of, I know we're coming up to time here. Great conversation. We've learned a lot about all the complexity of managing resources within Kubernetes and the way Kubernetes works and how its scheduler works and all the dials and knobs that you have in order to maximize or at least try to get the most juice out of your existing clusters. It's not an easy thing. You really need to understand what's going on inside of your cluster, how Kubernetes works, how these dials and knobs and requests and limits and priorities, etc., work. A lot of experimentation to really know what ends up working. So maybe we should wrap up today's podcast, Joe, talking about what is the biggest issue currently with the state of utilization management in Kubernetes.
I think the biggest issue is that this whole model that Kubernetes has landed on of micromanaging individual workloads and scaling individual pods and even scaling deployments and having things running in the cluster that are monitoring every workload and trying to make decisions on it, it just doesn't scale. There's parts of it that don't scale because sometimes there's just too much going on in the cluster. There's an inherent delay between there's a sudden spike of activity and being able to react to it, right? And there's always the risk that if you overreact, you're either going to spend money that you shouldn't have spent in the first place, or that you're going to have a situation where you scaled things down to the point where even normal workloads can't run because, when things return to normal, there aren't the resources to handle them anymore. So this micromanaging approach just doesn't work. And I think the biggest problem is that Kubernetes itself does not provide, like I mentioned before, that with VMs, there came to be the idea of overcommitting. There is no overcommitting in Kubernetes. But you need a way of looking at and managing your cluster resources as a unified whole that just isn't really there.
Interesting. So that sets up a possible future podcast for us, Joe, to talk about, are there solutions to this problem? And how do you go about solving this whole cluster utilization issue, right? As opposed to the individual pods and individual nodes. There's some things that don't exist. Overcommitment doesn't exist. Like migration of pods doesn't exist. And as a result of all of these dynamics, you end up having very poor utilization in your clusters, which is a problem. People are trying to fix it, but it isn't an easy way of resolving that. So with that, Joe, do you have any final thoughts before we wrap up today's podcast?
I guess my final thought is I can't wait for the next live stream where we can actually discuss how you actually solve these sorts of problems in a holistic way.
Yeah, I'd look forward to that. Maybe in a couple of weeks, we should get back online and discuss the various solutions that are out there. And every solution has a pros and have pros and cons, right? We just have to understand what they are, and depending on your workload, your context, your situation, figure out what's the best solution for you. So we'll get into those details in the next episode. In the meantime, we have you can go to our Cloud Native webpage and sign up for our newsletter. You will get advance notice of upcoming episodes, so you can sign up and join us as we have these sessions. So Joe, thank you so much. That was very enlightening. Lots of detail here that people may not be aware of, right? I mean, you have to go read the documentation. As you said earlier, most people don't. And they get hurt and then they say, what happened there? And then they go to the community or maybe put up a Slack message somewhere or Reddit message and try to figure it out the hard way. So come join us in these episodes and these podcasts and learn more going forward to address and manage your resources in your Kubernetes deployments. So with that, we'll wrap up today's podcast. And Joe, let's catch up in a couple of weeks.
Sounds great. And hopefully my camera will work better next time.
Yeah, it worked. So we're good.